السلام عليكم.
عليكم السلام استاذ محمد، صبحك الله بالخير.
عليكم السلام ورحمة
الله بالخيرات والامورات.
الله يطول عمرك، شلونكم؟ طيبين ان شاء الله؟
الحمد لله، الله يسلمكم.
الله
شكرا
يسلمك.
على الدعوه.
الله
ان شاء الله نكون اهل اليها.
ان شاء الله. انتم الكفاءه الموجوده عندنا في البحرين وعلى مستوى المنطقه، واحنا نتشرف امانه نستضيفكم معنا في فعاليات شباب الاهليه تواصل اهليه يوث كونكت من اجل تعزيز مهاراتهم لسوق العمل ان شاء الله.
ان شاء الله ان شاء الله وان شاء الله نفيدكم عن طريق البرزنتيشن اللي راح نقدمها
ان شاء الله.
ان شاء الله.
ان شاء الله.
ان شاء الله.
إذا أعزائي أعضاء الهيئتين الأكاديمية والإدارية، أعزائي الطلبة والطالبات، راح نبدأ إن شاء الله الآن محاضراتنا القيمة مع الأستاذ محمد ناصر من شركة ألومنيوم البحرين، فليتفضل مشكورا. تفضل أستاذنا.
شكرا أستاذ، شكرا على التقديم على المقدمة. ما أدري يطلع عندكم البرزنتيشن حاليا؟
نعم واضحة البرزنتيشن.
شكرا.
شكرا. تفضل.
First of all, I would like to thank you for inviting me for this presentation, and I would like to start straightforward, not to delay anybody from your side upon the presentation. So the presentation will be in using ALBA, and mainly we'll focus first. We'll take a quick brief about ALBA, and then later on we'll talk about the general control philosophy in ALBA, what we are using in common and major of the plan, and the major of the plan. Okay. There's just to elaborate that this is a confidential document and it shouldn't be copied or forecast or cascaded to any place. This is about the presenter. The presenter graduated from University of Bahrain. He had 24 years working in ALBA as professional work. I was working in plant maintenance for 17 years. Then I had been transferred to engineering and infrastructure as E&I automation engineer. Of course, I have an experience in electrical equipment maintenance, plant instrumentation and automation, together with the engineering project and engineering automation. So other I have in the electronics and the troubles. Okay, we'll move to the agenda of this presentation. Of course, as a rule in ALBA, we have to start with safety share. Any presentation, any meeting, we should start with safety share, and then we'll have a quick review to ALBA in number. Later on, we'll go through understanding ALBA process, how ALBA process in general, and finally, before that, we'll have a look to the ALBA focus, what ALBA is focusing on, the main focus point for ALBA management. And finally, we'll go through a little bit technical regarding the same presentation, which is process control system used in ALBA, widely used in ALBA. So we'll start with the safety share. My safety share will be talking regarding the road traffic. Of course, so many young people are here and there. They are not obeying whatever traffic rule in ALBA, so we insist all of us, all of the audience, to maintain the speed limit and to avoid using mobile, which is more dangerous nowadays, and it causes a lot of accidents on the road. Avoid using mobile at all at your driving, and whenever you need to talk or to text or to read any text, don't say it is only a millisecond or microsecond. It doesn't matter. A lot of accidents could happen during that period. So it's better to avoid rather than having something which is not acceptable. The next thing, that traffic light. Whenever we are reaching the traffic light, most of the people are accelerating to avoid the traffic light from changing over green to yellow or yellow to red. So they are overspeeding, and that is logically it's not right. Although so many people they are doing it, but even though it is not right. The last thing is to keep a safe distance between you and the vehicle which is in front of you. According to some study on the website I go through, the action for the human to react in case of any incident happening in front of him, average time required is 1.5 seconds. Okay, some people they could have the reaction before, some people a little bit after, but the average to react to any incident happening in front of the driver, it needs 1.5 seconds. So you need another 1 second to apply a brake and for that brake to take place. So it's better to avoid, to keep a safe distance between. Okay, the next is ALBA numbers. We'll talk generally in ALBA number. Everybody knew that ALBA started in 1971 and it was having only one reduction line. Later on, after 96, it has been changed to the largest smelter in the world in single place, excluding China. ALBA also, they have 2% they are producing 2% of world aluminium. Whatever aluminium required by the world, ALBA contribute 2% in that. ALBA Plan 6, the general or the target production, it is 1.54 million ton capacity or target. The next, ALBA added 12% of Bahrain gross domestic product. So ALBA contributed as 12% of gross domestic product of Bahrain. ALBA floating a public share in the market, which is 10% free. And the final thing is the number of employees in ALBA is 3,200 employees, which is where 84% from these are Bahrainis. Okay, next point, which is understanding ALBA. So we will talk about ALBA and how it is. ALBA mainly, it is a smelter. And the smelter, it is reduce the content of the raw material, which is Al2O3, we name it alumina, and to break it up to only Al. That's why it is a reduction because it reduced the content from Al2O3 to Al. So there's the raw material of alumina, and from this raw material to break it up, the electrolysis process, it is in use, where the final product it came as molten aluminium, which is only Al, pure Al. This is the main process at ALBA. So ALBA as a whole, it is to convert the alumina to aluminium. That's the main thing. To do that, it is required to have a place where the electrolysis process will take place. So that electrolysis process is done in a shape where we name it a pot. It is a cell where it is having a cathode underneath and anode at the top. For that, to operate that pot, it requires several things or several raw material to operate that pot. Majority of that material, it came from abroad, from outside Bahrain. So at Sitra, nearby Sitra, we have calciner and marine plant, which is a little bit away from original ALBA plant. At that calciner and marine plant, they receive mainly three raw material. The first thing, it is the alumina, which we talked about it previously, and that alumina, it is fed through the GTC or FTP, gas treatment center or fume treatment plant. It is fed to the funnel on the top of that box. And on time base, it is feeding alumina to the pot. And second thing, which is imported through calciner and marine, it is the petroleum coke. So that green petroleum coke, it came as volatilized material. So at calciner, they exerted to a very high temperature to remove the volatilized material, and it came a big coke, or we name it calcine coke. So calcine coke, later on, it is fetched to carbon, not to direct to the pot where we need it. No, the calcine coke, it goes. Then the third material, which is imported from outside through marine, ALBA marine, it is liquid pitch. And same liquid pitch, it is nothing done in calciner, it is directly pitched to the carbon area. At carbon area, we have three places or three parts. The first part, it is base plant. The second part, it is kilns, and the last part, rolling shop. So mainly at carbon plant, what they are doing, they are taking the calcine coke and the recycled anode, breaking it up to pieces, and they mix them together, and they use the bit, the petroleum, the liquid bit, to bond that material to form the anode. And later on, it goes to the kilns, where it is exerted to very high temperature, which is around 1100 degrees. And finally, it reached to rodding, where they put a rod up on the top of it. Like in this sketch, you can see a black color here represent the anode, and on the top, the blue bar and the brown bar or Moroni bar, it is part of this rod. We name it spider and the rod. So this spider and rod, it is fixed or bond through cast iron metal to the anode. And then later on, it is taken to the pot, and the old one, which is from here, it is taken back to the rodding, where it is again removed all the remaining material, which is the anode, and it is taken back, that remaining material from anode, taken back to the base plant, and in base plant it is crushed back to small pieces and reused. Okay, and the third thing, to operate this, now we got the alumina, we got the anode, the cathode, it is imported from outside through Bahrain marine board. So we got the anode, we got the cathode, and we got the raw material, which is the alumina. So this is forming the reduction cell, which we name it as pot. And that pot, there are a multi-pot in ALBA, which is forming a reduction lines. A reduction lines, it is a duplicate of the same cell, the same principle. There are a couple of technology used in ALBA, but all of them based on the same principle, electrolyzer principle, where we feed the alumina, we have anode and cathode through very high current moving through the Al2O3, which is the raw material, and the name is alumina, it is breaking up and reduced. For that, we need a very high power, which is a huge power. Like in the old boat line, it can reach to 140 kiloampere DC. Where in line 4 and 5, it can reach to 400 kiloampere. And in line 6, the target is around 500 kiloampere. To have all this amount of power, there's a power station plant. That power station plant only to generate the required power for the reduction line and to all ALBA process. And that power, it is around 3.5 gigawatts or more than 3 gigawatts. And finally, once it is done, through the sectioning of the molten material, which is the blue color here, the molten aluminium, there is a sectioning of that, and it is put inside this, we name it as a crucible. It is what we can say a metallic part where they put a special block inside to maintain the temperature. So the material which came out from the wood, the temperature is around 970. So it is poured inside this crucible, and from the crucible it is transferred to furnace. And that furnace, it is located in cast house. Cast house, there are a couple of furnaces, and that furnaces, it is having three purpose. First purpose is to handle that material. This crucible maximum, like some of crucible in ALBA, it is holding 5.5 ton, but other crucible, which is 9.6, it is holding around 14 to 15 ton. While a single cast, if it is started, it requires around 60 to 80 ton. So to do that, we need to hold whatever material transfer from reduction line, which is the boat where the electrolysis process it is taking place, to transfer it to the casting side. We need to hold that material to multi-crucible. It is poured there, and we reach the amount is holding. Second thing, mixing. Depend on the customer requirement. Like some customer, they require this much aluminum, let us say 90%, 2% they need iron in that, and 1% they need silicon. So there are some addicted the customer is requiring or requested at the time where he placed the order to ALBA to buy aluminum from them. So during that holding, they mix that material inside, and later on they took that sample, very small pieces or small amount of that, whatever they are mixing, and they send it to a place where it is a laboratory, but they give it a special name, quantometer. The quantometer will assist through X-ray that how much the content of that metal small piece, which is taken as a sample from this furnace, to analyze it and to see whether it is suiting the requirement of that customer or not. And finally, casting. Casting, that means shaping the final product which the customer is acquiring. Whether it is ingot, whether it is standard ingot, whether it is billet slab. And in the next slide, you will see the type of product where ALBA is casting and produced. So there is standard ingot, rolling slab, and alloy ingot. Molten metal, it is going direct to middle cable, and there is T ingot also, and extraction billet. This is ALBA in a brief. Next, we reach to the point where we'll talk a little bit about what the major point that ALBA is focusing on. So the first point is health and safety. Of course, once we say health, it is not only health as a pure health, it is included the morale of the employee. So to assure that employee they have a good morale, ALBA is offering to its task force the scam, we name it ALBA scam. So they are giving them a loan, or sometimes they are giving them houses, they build a special scheme. And also medical insurance, they offer to all employees a medical insurance and savings scheme when it is some percentage deducted from the salary, and it is accumulated where the company itself, it is contributing that little bit. So by the end of the serving period in ALBA, you will get some amount of money that it can be useful later on for you. And also there are other employee benefits like the bonus, like Ramadan basket, like a school basket. So all this is to boost the employee morale at ALBA and to make them at safe place with good morale. The next slide, it is talking about safety. Safety is believing on, ALBA is believing on safety as a major role in its operation and its production. So ALBA is forming a rule which is very simple and very objective, and all the guys, even the contractor, he can understand it and he can follow it. So the first one is ownership of safety and environment. So safety, it is not a safety. We believe also the environment, it is having a big role in our production and our operation. So ownership of safety and environment, it is not the management, it is everyone's responsibility. The second thing is safety. I mean, working safely as a one team. So it is not independent. We are one team, one family in ALBA, working together. Working safely as a one team is a condition of employment. And the last one is all work-related injury and illness are preventable. That's why at ALBA, whatever happened, like small incident, we are forecasting it just to avoid, to teach the people that avoid anything that it could reach to any incident. So anything it could reach to any incident, it is highlighted to ALBA through a special system, to all ALBA employees. Okay. As I believe in safety, there is a record, and that record, it is measuring loose time injury, like how many loose time injury we have in this year and next year and year after. So if you saw from this trend, in 2010, we were having, as a whole year, we were having 19 injury. It is not lost time, it is only injury. So from 19, alhamdulillah, in 2021 till date, we don't have that one. It is zero. Although we have 3,200 employees and it is a huge smelter, but we are safe. So one of the safest smelter in the world. And also, if you look to the injury trend, how it was, so the injury here, it is lost time. So it is lost time injury, while here it is only injury. So the total injury was 121, where it fall down now to 2 injury. So the difference between this injury and this injury is lost time, that the employee, he could have a rest or something. But in the below trend, it is measuring only the injury, where the employee, he don't need to have a rest or any special medical attendance. Let us move. One of the bonds which ALBA is focusing on is the fume treatment, where whatever they are going from the reduction line, there will be a hydrogen fluoride, carbon dioxide, all it is treated through a special plant. There are a multi-plant, and it is dealing with that toxic fumes, and these are contributing and protecting the environment a lot. There are FTC, which is Fume Treatment Center. There are FTB, which is a Fume Treatment Plant, and there are GTC, which is Gas Treatment Center, and all of them, the main aim of establishing them is to assure that whatever toxic gases, hazardous gases, environment unfriendly gases is treated at that basis, and then whatever fume came out from the chimney, it is clean, environment friendly, and non-toxic fume. And also ALBA is looking for greenery. So if you look, there is an oasis in ALBA, and that oasis, it is surrounded by greenery area. That greenery area, even the vegetable, it is growing there. There is a proof that the place is environment friendly, and the vegetable and all the sort of bird and so on, it can go there. We move to the next one, which is social. ALBA believe that there should have a commitment towards social. So it contributes a lot in social activities. Maybe due to coronavirus, it is a little bit limited, but even though it's still there. So one of the activity was cleaning of Askar Beach. So these are ALBA employees. They have summit at Askar Beach only to clean them. So this photo was taken for that activity. And also ALBA contributed in Ahlia Beach, and the same thing that ALBA play a big role in Injaz and Bahrain. So employee, part of them, they gone and gave some special session, special contribution to Injaz at different places, at different school. And even our CEO, he appreciate all the contributor by giving them some award, and there's one of the contributions ceremony, appreciation ceremony. Okay, the next thing is training. Training is a big role, or a big, to develop all the workforce. You need to give them a training which is required to improve their capability and to boost their knowledge about what they are doing. So ALBA, it is believing in that. That's why greater than in 2020, this record is for 2020, greater than 5,000, 500,000 training hour, and 441 courses was there in 2020. Of course, majority it was virtual. There was not actual attendance, but it was through Teams and other application. In 2020, there was 40 courses. Of course, ALBA believe that it should boost its employee also through special certification. That's why 5 MBA candidates in 2020, 2019, and 4 new MBA in 2020, 21. The next thing is the production. Of course, if you observe the production, which is the major objective of ALBA, that's why ALBA is there, is to produce aluminium from raw material, which is alumina. So in 2013, the production was 913. Where it reached to 2018, not very sharp increase, because it was for some of the improvement here and there, so that the production was increased. But if you saw in 2019 and 2020, there is a boost in the production. Why? Because of Line 6. So as we said previously, Line 6 objective is 1,540. So in 2020, we exceeded the target by 8. So this is ALBA and focus. What are the main focus point for ALBA? We read to the main topic of this point, this slide, which is process control and ALBA. Of course, ALBA is using a loop feedback to control its activity. And the major part of this feedback control, the control logics and PLC5, there is still some of the plants, it is having distribution control system, but this later on it will be upgraded to the PLC, but still it is there, some of the places. That's why I put it there. So what is PLC5? PLC stands for Programmable Logic Control. Before this, at the beginning in 1970s, before PLC5, there was SLC, which is Sequential Logic Controller, which is having a very limited capability, and also it is not functioning that much, very difficult to access the program, very difficult to troubleshoot through the program. Then PLC5, the new renovation for that, it came as PLC5, where it is migrated to Control Logic, which is totally different platform than PLC5. If you saw the photo, this is the PLC5 chassis, where the PLC, the controller of PLC5 is here, and this is the power supply, and these cables are the termination to the I/O. I/O stands for input and output module. Of course, input, it could be the secret input, it could be analog input, and same as output, analog, the secret input and output. These are, this is the control logics, which is the new generation, the new platform of the VLC5, next to the VLC5. So now Allen Bradley or Rockwell, as Allen Bradley is the hardware and Rockwell was the software. So all together it came as Rockwell Automation. So they have the new platform, which is control logics. And that control logics, it is having a controller. It shouldn't, it is not a must that the controller, it is only single controller. It could have two controllers, like this photo, it is having two controllers. One in the first slot, which is slot 0, and one in the fourth slot, which is slot 3. And there are input and output, we'll talk about them a little bit. This is the way it is connected. I mean, inside the panel where the control logic it is located at the top, and there's another control logic underneath. Why we have to do this for redundancy purpose? Majority of the plant or most of the plant in ALBA, it is very critical plant where if you have any problem with the control logics, which is controlling the process, if you have any emergency, any breakdown, you cannot continue, it is not tolerated. There should be another alternative which will start from the place that the previous control it is stopped at. That's why these are the way. There are two PLC chassis or control logic side chassis, and underneath this side and this side, it is the connection or the input and output module connection through the flex IO going to the control Ethernet port, Ethernet card, and from Ethernet card it is connected to the controller. So these are the redundancy. For Laplace control, we have in ALBA only at quantometer building. Quantometer, we spoke previously about it, that a small sample, it is taken out from the furnace where the molten aluminum, it is held there, and some additive, it is added there. Then later on, small sample, it is taken out from there, and it is sent to the quantometer building, which is actually an X-ray lab, and that X-ray lab, it is quantifying how many additives has been added to that material, and once it is okay, an order given to the operator to start casting. So at that place there is a robot, and that robot it is having Laplace control, transform controller. But this program it is preset by the supplier of that robot, and ALBA they don't have any access to that one. It is only by the supplier of that robot. We'll have in the next slide a short video about the robot, how it is working. This is the robot, how it is working. And you saw that it is pneumatic and it is having a cascade control with the supplier of this. This is the small piece where it is given from the furnace of molten aluminum after mixing the addictive to it. So it is very clear how the cascade control it is taking place here between the robot and the other machines. So if the other machine is not ready, the robot will not move there to the next cell. Okay, we read to the hierarchy at ALBA. ALBA is having the control of each machine, device, equipment in its place. So at level 1, we will be having a multi-VLC, of course. In ALBA, we speak or we spoke about the VLC as control logic. We name it VLC also because it is a programmable logic controller. Only the platform is different, but still it is a logic controller. So at level 1, we have instrumentation, PLC, and controller. We name it as level 1. Then in level 2, where multi-PLC, multi-controller, it will be jointly going there for the server and for the control room and so on. So at level 2, we have a real-time system. We name it as SCADA. SCADA stands for System Control and Data Acquisition. This is level 2. Then from this level 2, which is going to level 3, where manufacturer execution system. It is a special software, a special firmware with the software. It is collecting all the information from level 2 and array all the required reports and so on to this executive or to the higher level. The next level, it is SAP system. SAP, it is the manufacturer of the software, which is German company, and all the activities in ALBA and the control, it is part of them. There are other equipment and facilities are there in SAP. So I think there was a technical error, so forgive me for that. Okay, next slide is now the new hierarchy in ALBA. Before we saw like pyramid hierarchy. Now it is a flat hierarchy because we are going for a software, we name it Industry 4. So in this hierarchy, it is having all the level 1, level 2, level 3, 4, 5. It is connected with each other with a special interface. This interface will facilitate, like if you are at level 4, let us assume, and you want to access some feature or some information in level 1, you will be able to access provided that you got that privilege to access. And this is done through a special interface. So it is a flat controlled hierarchy, but with a special facility, special feature, special privilege given to everyone, every user. And that later on, it can go to your mobile, it can go to your internet, whatever PC or laptop you have, and it is there on Amazon Cloud. Okay, next we reach to the process control terminology. So to control any process in ALBA or anywhere, we should have a control terminology. In these places, we have control variable, which is in this illustration, it is the level of this tank. So to control the level of this tank, a board of whatever valve it is taken out the liquid from inside, we should control the level. So to control the level, we name it control variable. The control variable will be fetched to the level controller. Level controller will get the set point from the PLC, from the control logics, or from anywhere, and then later on, it will form a signal which is going to the valve. And that valve, it will control the flow. So the flow, we name it as manipulated variable. So it is not the control variable. The control variable, it is the level, while the flow, which is controlled by the opening of the valve, it is a manipulated variable. And the signal which is going from the level controller to the control valve, we name it a control signal or control output. And the error signal, which is there, if we saw it, the error signal, it is the difference between set point and the major signal or control variable. The error is the difference between both. Once it is there, then it will generate an output accordingly, according to the error, to minimize the error. So these are the main terminology used in ALBA. We reach to the point where we will have little log to the controller or the PLC or control logics, which ALBA widely used as control to its process at level 1, as we say. The first one, which we talk about it, now is obsolete for Rockwell automation. We name it as PLC 5. And the next one, there is sequential logic controller, but there is not the original one. The original one, which was there before PLC 5, it was sequential logic controller 100, and that was having very limited feature, while this SLC 500, it is having a widely feature, but not too wide, extra wide. It is widely there. And there's micrologics, where it is having a special software also. There's a micrologic, another type, which is more feature, more program capability to do. Even some PID controller, proportional, integral, and derivative, it can be programmed there. Micrologics also same. And then compact logic. Compact logic, it is very limited feature. But if you need to control like some levels, some AC at your home, if you have central AC or something, you could use compact logic. Easily you can program it. You can troubleshoot in case of any failure of sensor devices. You can troubleshoot it through the software of this compact logic. Then the control logic. This is the high version of among all these, which is having very huge capability, very huge feature, very huge facility to program it. Then, finally, we reach to the panel view in level 1. Panel view in level 1, the purpose for that is a front-end software for the operator. Normally, the operator, whoever, he don't have capability, he don't have feature to access the PLC software. So the PLC software, it is controlling some machine. So the operator will be responsible for that machine. In case he need to run that machine, or he need to do some sort of arrangement to that devices, machine, equipment, he cannot access to the PLC. So the interface between the operator and the machines through the PLC is the panel view. The panel view, or sometimes we name it HMI, Human Machine Interface. So the software will be there, where graphical view will be there, and all the numerical data from the PLC will be shown there. And some of the panel view, it will be only monitor. So he will be able only to read the data. And in some of them, he will be able to control that, to close some valve, to start one motor, to stop motor, and so on. So all these are types of panel view are widely used in ALBA. And the same control logics, we name the major control logics, or the huge capability control logics is control logic 5000. There are a lot of input and output. The one which having a black spot on it, it is a controller, the PLC system, the programmable logic controller. There are two in this photo, and these are input card and output card. So for this, how many input and output card? We have the secret input, we have the secret output, analog input, and analog output. Then we have device net. Device net, by the time it will be obsolete. Now it is in service mode. Later on it will be obsolete. And we have control net, which is more or less it got obsolete. Then, but still, some places still it is in use. Even ALBA, I think it is there. Ethernet, it is widely used and still it is in use. Then fiber optic, where fiber optic cable, once you do splicing to it, you can hook it direct to that card, which is located in the same chassis. And then we have redundancy card. Redundancy card, the purpose for it is to synchronize between two controllers, like the one which we saw previously, that we have two control chassis, control logic chassis, and redundancy was there, so to assure the synchronization of all the information between two controllers, redundancy card, it is in use. RTD, it is to measure the temperature, resistant temperature deflection. Before we use this to have a transmitter where we connect the probe of the RTD to that transmitter in order to get 4 to 20 milliamp out of that transducer. While now, Rockwell Automation, they generate a card where we can put the probe, connect the probe direct to that card. We don't need any transmitter in between or transducer in between to convert the different and the resistant to milliamp. As we said, in ALBA, the most control philosophy which we are using on-off control and BID control, proportional, integral, and derivative control. If you observe from here, the proportional, it is the green one, while integral, this is the set value. The integral is the red one, and the derivative is the black one. The combination of the four, this is our the one which we are using in the plant. So to elaborate that, the signal which we give as a set point and the feedback signal, it is summation. There is a summation for it, an error signal between the control variable and the set point. There will be error signal. That error signal will be fetched and executed by proportional, integral, and derivative, and all these will be summed together after that, given to the plant to process, like the one which we saw previously, given to the control valve, and the control valve, once it is operating, then again the level will be measured and will fetch back, and then this area where the error will be generated by comparing the control variable and the set point. In the same Allen-Bradley control logic or controller or programmable logic controller, we have a couple of ways to program it or to write the program to control the input and output, and to program the virtual equipment like virtual relay or virtual process inside the controller itself. To do that, we need to write the logic or the program which we need. So there are a couple of ways to write the program, like relay logic or ladder logic, we name it. And these are the example of ladder logic. Then we have structured text. It is very clear from the structured text, it is here. These are the structured text. Then we got a functional block diagram, which is here. So it is a block diagram where input and output so functional block, and then sequential function chart. So these are the sequential function chart, like it should go in this way, then there will be some condition inside the block. So these are the sequential function chart. So four way to write the program, and ALBA majority, it is ladder logic. Some places we are using sequential function chart, but other two, it is very limited. This is a video which will show you that the crucible, which is used to transfer the material from the reduction line, the molten aluminum from the reduction line, and we name it crucible. To transfer it time to time, there will be growth inside. Growth is unwanted material which is accumulated inside, and it will reduce the amount of the transfer material. Like in case I am transferring 12 ton bare load. After accumulation of whatever remaining material inside, it will reduce to 8 ton bare load. So from 12 to 8 ton, it will not go. That's why there is a place where this crucible is cleaned up and reused again as a clean crucible. So again, instead of 8, it will go back to 12. So we name it as crucible cleaning machine. And this video will show you how the crucible cleaning machine is working automatically. Only the operator at the beginning, he needs to remove the crucible by the crane, and located in the table of that machine, then everything it is going on automatically, nothing, no intervention, nothing done manually by the operator, everything in auto. It will tilt the crucible first, the table will tilt the crucible, then the hood will cover that area in front of the crucible because some fume will be generated while cleaning, and that hood it will be there in the place, and the outcome or an extraction pipe, it is going to the dust collector where it will treat that fume. Let us start that video so you can see how it is working.
أستاذ محمد بس الفيديو بدون صوت.
الفيديو ما في صوت، اشتغل عندي ما يشتغل. في حركة بالفيديو؟
لا ما في حركة.
السلام عليكم. خليه بس الكل برضه اشغل يمكن لانه كان طالع لي تكنيكال قبل شوي.
بعد مثل المشكلة ما يشتغل.
I think the size of this video is a little bit huge, that's why maybe it is not working. Forgive me, I will leave this and again I will access maybe some technical connection. Just 1 second if you don't mind. مو راضي يشتغل. I think we'll end up. Thank you and sorry for the viewer.
أتوقع مو من نصيب الطلبة يشوفونه. شكرا جزيلا يعطيك العافية أستاذ محمد.
شكرا حاضرين. And I hope I give some information to the student and to everybody which is useful in their career.
شكرا جزيلا أستاذ محمد ويعطيك العافية وما قصرت.
شكرا.